Okay, here's the solutions to section B. So question 1, we have between 0 and 2 pi, and we want to solve 3 sec squared theta plus 3 sec theta equals 2 tan squared theta. Okay, well, you should notice that that's sec squared, that's tan squared. You can change anything that's got a squared in, but we can't change stuff that's got no squares in. So sec has to say sec, so it makes sense to change everything in terms of sec. So I'm going to change the tan squared there. So I'm just going to write down the identity over here. So it's 1 plus tan squared x is sec squared x. So to get tan squared, it's just sec squared. So sec squared theta minus 1. I'm going to stick that in brackets, times by the 2, and then the left-hand side is going to stay the same. So expand the brackets. I'm going to take everything to one side. And I'm going to make a substitution. Y is sec theta. So if I do that, it'll become y squared plus 3y plus 2 equals 0. I'm going to sub that in my calculator, and I'll get two answers: y equals minus 1 and y equals minus 2. Now, don't stop there. I sub back in what y is. So sec theta is minus 1, or sec theta is minus 2. But remember, I don't have arc sec on my calculator inverse sec. That will change that into cos. Remember to get cos, because sec is 1 over cos. I did reciprocal on the other side. So 1 over minus 1 is minus 1. And 1 over minus 2 is minus a half. Solve them. So make sure you're in radians. And do inverse cos of minus 1. And we get pi. So our first answer is pi. And to get the second answer, remember we do 2 pi minus. So 2 pi minus pi. Well, that's just pi. Didn't need to calculate that. And next one, do inverse cos of minus a half. And we get 2/3 pi. And to get the second answer, do 2 pi minus that answer to get 4/3 pi. So our answers are 2/3 pi, pi, and 4/3 pi. Now remember, you can use solven to check that. I'm going to leave that bit for you to do. Okay, so that's question 1 done. Question 2. So we've got something on the slope. Its mass 2 kilograms. It's been pulled up by 80 newtons and the angle is 20. We know it's a rough plane. So that means it's going to be a coefficient of friction mu. We know that it's going to be the weight 2g going down. It's going to be a normal reaction. And if it's being pulled up the plane, there's going to be friction going down the plane. Okay, straight away, pick your two directions. So this is my vertical, that's my horizontal. So I want to split that up into a bit down and a bit down. That angle there is 20. So this must be 2g cos 20 because it's adjacent. This must be 2g sine 20 because it's opposite. Okay. It says the coefficient of friction is 0.6. And we want to work out the normal. Well, to get the normal, I'm going to do F equals ma in the normal direction. So R is going in that way, 2g cos 20 is going that way, and it equals, well, the acceleration in this way is 0. So I just get R equals 2g cos 20. You might jump straight to the step, doing up equals down. So 2, make sure you're in degrees for this one. Let's get back into degrees. 2g 2 times 9.8 times cos 20. Get r equals 18.417. But I'm just going to have two significant figures, so 18 newtons. Now I'm going to store that in my calculator because I'm probably going to need that for the next bit. I'm going to store that as R because that makes sense, doesn't it? So call that R. Okay, and then part B says by modeling the box as a particle, so that means I could ignore the surface area, stuff like that. Find the acceleration of the box. So that just means we need to do F equals ma going up the plane because the acceleration is going to go this way. Now, before we do that, we need to work out what friction is. So I'm going to use the friction formula. Since it's moving, friction equals mu times R. Well, friction, mu is 0.6. Friction is R, so I'm going to do 0.6 in the calculator times R, which should give us 11.05, etc., etc. And again, I'm going to store that as F in my calculator. Okay, and I'm going to use F equals ma going up the plane. So I have 18 going up, take away friction going down, take away 2g sine 20 going down, and that equals ma, so 2 times a. So to get a, it's 18, take away f, take away 2g sine 20, then divide all that by 2. So 18, take away f, take away 2 times 9.8 times sine 20, divided by 2. So for a, I've got 0.122, so two significant figures, 0.12 meters per second squared. And that's 2 done. Number 3. So we've got y equals 2x, x squared minus 1 to the power 5. And we want to show that dy by dx is gx, x squared minus 1 to the power 4. Now, this gx bit, g of x, just means that I can factorize out this term and I'll be left with something. If that confuses you, just ignore it and just differentiate it. And then see you can try and get the answer from there. So differentiate it, it's 2x times that. So that means we need the product rule, so we need a u, and we need a v. We need to differentiate them both. So 2x goes to 2. Just differentiate this, remember, power goes to the front, take away 1 from the power, then you need to remember the times by the bracket, the substitution. So x squared take away 1, differentiates to 2x. So that's 5 times 2x is 10x. X squared minus 1 to the power 4. Remember, write down the rule. So dy by dx is u v dash plus v u dash. Sub it all in. So I've got 2x times 10x x squared minus 1 to the power 4 plus 2 times x squared minus 1 to the power 5. I can simplify this a little bit here. It gives me 20x squared, x squared minus 1 to the power 4 plus 2 x squared minus 1 to the power 5. Well, there's common factor. If you look, well, I can take x squared minus 1 to the power 4 out and 2 out. So 2 x squared minus 1 to the power 4. Big bracket to see what's left. I took a 2 out, so I'm left with a 10x squared. And I took 4 of these out, so there's 1 of these left. So there's 1 x squared minus 1 left. Now all I need to do is just simplify this bracket. So x squared minus 1, 10x squared plus x squared is 11x squared minus 1. So there we go. Like if I just write that in the form at once. So 2, 11x squared minus 1, x squared minus 1 to the power 4. So this bit there is my g of x. Or I could expand it and get 22x squared, take away 2. And that's that one. So number 4 next. So we have geometric sequence. Second term is 750, and fifth term is -6. And I want us to find the common ratio. So for this, our knowledge we need un or n-1. That's our knowledge. So I'm going to use that to get me an expression for the second term. So a or 2 minus 1 is 1 equals 750. A or 5 minus 1 is 4 equals -1. That's equation 1. I'll call that equation 2. So simultaneous equations, I'm going to do 2 divided by 1. So I get a or 4 divided by a or is -6 divided by 750. A's cancel out. R 4 divided by r, this gives me r cubed. -6 divided by 750 gives us -1/125. So then cube root it. So r is -1/5. Okay, I'm just going to put that there. I'm just going to leave that for the next part. Part B is asking for the first term. So I pick one of those equations and sub it in. So I want to pick that first one. So a times -1/5 is 750. Well, to get rid of -1/5, I'm going to times by -5. 750 times -5 is -3,750. So we've got a. And then part C says find the sum to infinity from the series. So just to double check, remember, I can only do the sum to infinity if r is between -1 and 1, and it is. So I haven't made a silly mistake there. So I need this formula. This is my knowledge, and you get given this in the formula sheet. So just sub it in. So S infinity is a -3,750 over 1 minus -1/5. And just type that in your calculator. And you should get -3,125. Okay, and the last one. So we've got a rectangular enclosure. That's X, that's a wall. And that's made out of rope, and the rope's 20 meters long, so that will be X. So that's got 2X so far. So this bit here must be 20 minus 2X. And it says, use differentiation to find the maximum value. A is the area. So area equals length times width. So area equals 20x, take away 2x squared. It says use differentiation to find the maximum. So remember, the knowledge we need to know is at a maximum, dy by dx is 0 because it's stationary, and also d2y by dx squared is less than or could actually be 0 in very small number of cases. So we have this. So, well, if I differentiate it, so dA by dx, I get 20, take away 4x. And if I make that equal 0, I get 20, it's 4x, so x is 5. And that's my only answer. But if you really want to check its maximum, you could differentiate that again and just get -4, which is automatically less than 0, so it automatically is a maximum. So to get the area, just sub 5 back in. So 5 times 20, take away 2 times 5. So I could do that without a calculator. It's 5 times 20, take away 10. 20 equal 10 is 10, times 5 is 50. That's in meters, so meters squared. And that's all there is to it.